to fractions, the four operations. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So today we're going to start with adding and subtracting fractions, and we're going to begin with the question, how would we work out 3/5 plus 1/5? Well, just to start with, I'm just going to do this with a little diagram. If I show you a bar split into 5 equal pieces, then each of those pieces is 1/5. And so 3/5 will be 3 of those pieces coloured in. If I then show you the 1/5, the situation here is that we're going to add those two things together. And so all I'm going to do is I'm going to put those two diagrams together into one, like that. And so now, when we add them together, how much is coloured in? Well, out of the 5 pieces, there are 4. And therefore, this must mean that we have 4/5. And so if we have a look at this, 3/5 plus 1/5 equals 4/5. And in this you may notice that straight away the bottom number, the denominator of the fraction, has remained the same all the way through. And then all we've done is add the top numbers, the numerators, to get the top. Now the reason that that was so straightforward is because those denominators were the same to begin with. We started with both cases being fifths. But what happens if they are not the same? Well, we would get a question like 3/5 plus 1/4. If we go back to the diagrams again, 3/5, well, that would look exactly the same as it did in the previous question. A bar split into 5 sections, 3 of which were coloured in. And then for a quarter, well, that would be a bar split evenly into 4 pieces and only 1 coloured in. Now we can see straight away that these are not the same denominator, and so the pieces are not all exactly the same size in the bars. And that means we can't just do a quick adding together. What we need is to think about some equivalent fractions which may well help us to see we've got the same numbers. Now, one way that we can do that is if we make the 3/5, if we split each of those into 4s, as this was 4s here. So if I break it down into equal pieces, 4 equal pieces, 4 equal pieces, and 4 equal pieces, well, that would mean I'd also need to split the rest of it into 4 equal pieces. And so this first bar is now actually out of 20. How many of those 20 pieces are coloured in? Well, there are 4, 8, 12 of them. The second bar, if I wanted to make it so that it was the same size, well, I'll keep these lines going so that everything remains the same size. And what we'll actually notice is we've now got 5 pieces coloured in. The same thing here, we'd carry on drawing down. And what we've got is, once again, 20 equal pieces. So it's a fraction out of 20, but there are 5 of them. And so if we now put all of those together into one diagram, well, there we go. We've actually got how many pieces coloured in? Well, there were 12 red and 5 blue, so that is 17 in total, but it's 17 out of 20. And so 3/5 plus 1/4 is actually 17 over 20. Now, why is that the case? Well, because what we needed were common denominators, like we had in the previous question. So we had the common denominator of 5 in the previous one. We had to turn this question into a common denominator as well. In this case, we've used 20. And why have we used 20? Well, the reason is we're trying to find a common multiple of 5 and 4. And the easiest way to find the common multiple is actually just to multiply those two numbers together. We know we're definitely going to have a common multiple if we multiply them together. And then what we've done is the 3/5, we've turned that into an equivalent fraction, which is over 20. And the way we've done that is we multiply the bottom by 4, so we multiply the top by 4. 3 times 4 is 12. And for the quarter, well, we needed to turn that into a fraction over 20. How did we do it? Well, the bottom was multiplied by 5, and so the top is also multiplied by 5. And then, because we have the common denominators, we can then just add the numerators. So let's try to give this a go without using the diagrams. Can we just come up with a quick method? Well, in the first question we have 2/3 plus 1/5. Now the key here is we must always have common denominators if we want to add or subtract fractions. And so the common denominator, we have 3 and 5, so let's multiply those two numbers together so we have a common multiple. 3 times 5 is 15. And so both of my fractions are going to have a denominator of 15. Next, we just want to look at each fraction individually. What did we multiply by in order to make 15? Well, the first one, it was 3 times 5. And so because we multiplied the denominator by 5, we must also multiply the numerator. So 2 times 5 is 10. On the right hand side, what did I multiply 5 by to make 15? Well, that was multiplied by 3. And so again, I must do that at the top as well. So 1 times 3 is 3. Once we have a common denominator, all we then have to do is add the numerators. The denominators will remain the same at 15, but we'll get 13 at the top. In our second question, we have 2/7 plus 2/3. Well, in order to get a common denominator, let's just multiply the two numbers together. So 7 times 3, well, 7 times 3 is 21. So they're both going to be over 21. And then again, what did I do in order to actually make a denominator of 21? Well, in the first case, I multiplied by 3. So I'm going to do that at the top as well. 2 times 3 is 6. And on the right hand side, 3 was multiplied by 7 in order to make 21. So 2 times 7 is 14. Now that we have a common denominator, all we need to do is add together the numerators. So 6 plus 14 is 20. And finally, in the last question, we have 3/10 plus 3/5. Now, with what we've done in the previous questions, we've just multiplied the bottom numbers together in order to find that common multiple. And that is absolutely fine. In this case, it would be 50 in both cases. But what I'm just going to show you here is that we could do this a little bit quicker, because what we would end up doing in the question with the fractions over 50 is we'd need to simplify at the end. But if we look at the two numbers, we have 10 and 5. Is there another number which is a common multiple of 10 and 5? Well, they in fact both go into 10. And so we can just use the lowest common multiple if we can spot it early on. If not, we can just simplify at the end. It's absolutely fine either way. But in this first case, how did I turn the 10 into 10? Well, I didn't actually do anything. So the first fraction remains exactly the same. It's still 3/10. On the right hand side, how did I turn 5 into 10? Well, that was multiplied by 2. And so at the top, 3 times 2 is 6. And now that we have common denominator of 10, we can just add the numerators. 3 plus 6 is 9. We have 9/10. Next, we're going to look at subtracting fractions. And the reason I've put these two together, adding and subtracting, is they have exactly the same method. The only difference comes that at the end, obviously, instead of adding our numerators, we're going to subtract them. And so once again, we need to begin with common denominators. And so 3 and 4, the common denominator there would be 12. And so then all we need to do, as we did previously, what have we multiplied by to make 12? Well, in this case it was multiplied by 4. So 2 times 4 is 8. And on the right hand side, 4 times 3 made 12. So we multiplied by 3 at the top as well. And so finally, because we have the common denominator, all we then need to do is subtract the numerators. 8 take away 3, well, that would be 5, and so 5/12. In 8/9 take away 2/3, we're in a similar situation as we were in the last question on the addition, because in this case we could multiply 9 and 3 and get 27, but again 3 will actually go into 9. And so we could use 9 as our denominator in both cases. The first fraction remains exactly the same. It stays as 8/9. But the second fraction, well, that one has been multiplied by 3. And so we've got 6/9. We have the common denominator, and so all we need to do is subtract the numerators. So 8 take away 6 is 2. And then finally, 3/5 take away 3/8. In this case, again, we want a common denominator. In this case, 5 times 8 would be 40. At the top, I've multiplied 5 by 8 in order to make 40, so I need to do the same at the top. 3 times 8 is 24. At the bottom, on the right, 8 is being multiplied by 5, so I need to do that at the top as well. 3 times 5 is 15. And so 24 take away 15, well, that is 9/40. So next we're going to look at multiplying fractions, and the first question we've got is 1/2 times 3/4. Now there is a little trick with the multiplication sign. If we are ever dealing with fractions or percentages or decimals, when you see the multiply sign, you can think of it as the word of. And so this could be read as 1/2 of 3/4. So what is 1/2 of 3/4? Well, let's begin with 3/4. There's our diagram of 3/4. It's a bar split into 4 equal pieces with 3 of them coloured in. Now if I'm finding 1/2 of this, then I want to split everything here in 2, like that. And so this is still 3/4. We still have exactly the same amount coloured in, but we've just split everything into 1/2. But I want 1/2 of it, and so these 6 pieces, well, I need to get rid of some of them. I'll be down to just 3 of them. And so the answer to 1/2 times 3/4 is 3/8. We had 8 pieces in total, and 3 of them were coloured in. But how can I do that quickly without needing to draw diagrams? Well, let's see if we can spot any connections. We had 1/2 times 3/4 equals 3/8. Well, straight away at the bottom, I am spotting that 2 times 4 makes 8. What about the top? Well, 1 times 3 is 3. And so possibly we have a rule that we just actually need to multiply the top and the bottom. And that is exactly the rule. When we multiply with fractions, you times the top and you times the bottom. So let's have a bit of practice. 2/5 times 1/4. Well, really quickly, we just need to multiply the top of the fraction. 2 times 1 is 2. And 5 times 4, well, that's 20. Now with this, we should always be looking to see if we can simplify the fractions as well. Is there a number which will go into 2 and 20? Well, 2 will go into both of them, so we can half both numbers. It'll be 1/10. If I did 3/4 times 6/11, let's do the same again. Let's just multiply the top. 3 times 6 is 18, and multiply the bottom. 4 times 11 is 44. Have we got a common factor for those two numbers? Well, 18 and 44, again, they're both even, so we can half them both. It'll be 9/22. Is there anything that's going to go into 9 and 22? There is not, so 9/22 is our final answer. 4/7 times 2/3. Well, all we need to do is multiply the top. 4 times 2 is 8, and multiply the bottom. 3 times 7 is 21. Is there a number that goes into 8 and 21? No, there is not. That is the end. And finally, 1/6 times 3/8. Well, 1 times 3 is 3. 6 times 8, well, that is 48. Is there a number that goes into 3 and 48? Well, there is. In this case, the answer is actually 3. 3 goes into both numbers. So 3 goes into 3 once, and 3 goes into 48 16 times. So that is 1/16. And the last thing is dividing with fractions. So how would we work out 1/2 divided by 1/4? Now for this one, we have a very special rule. What we have is copy, change, flip. Now the reason we have copy, change, flip is what we're actually asking here is how many times does 1/4 fit into 1/2? And I'm going to show you this in a diagram again. So here is a half, and here is a quarter. How many times would that quarter fit inside of a half? Well, you can see quite clearly that if this is a quarter and here's another quarter, it would fit into the same place twice. And so my answer to this question is 2. How could I get that? Well, if I follow copy, change, flip, I will get exactly that answer. And it comes in copy, change, flip because it's all about the 3 parts to the question. We're going to copy the first part, a half. We're going to change the middle. Now, it is currently a divide. What can we change it into? Well, we're going to change it into a multiply. And we're going to flip the last part. What does flip mean? Well, it turns 1 quarter into 4 over 1. Now, what we have is a multiplication question. And so just like we saw before, when we multiply the top, 1 times 4. And we multiply the bottom, 2 times 1. And we get 4 over 2. And if we do 4 divided by 2, because that's all a fraction sign means, it means divided by, well, 4 divided by 2 is 2. So let's do a little bit of practice with that. Each time thinking about copy, change, flip. So 3 quarters divided by a half. Well, I'm going to copy the first part, 3 quarters. I'm going to change the middle to a times, and I'm going to flip the second fraction. Now this is just a multiplication, and so what we need to do is times the top, 3 times 2 is 6, and times the bottom, 4 times 1 is 4. Now we should also be trying to simplify wherever we can. Well, this is 3 over 2. That means 1.5, so 3 quarters would fit into a half, a half would fit into 3 quarters 1.5 times. 3 quarters divided by 7/8. Same thing again. We want to copy the first fraction, 3 quarters. We want to change the middle to a times, and we want to flip the second fraction, 8 over 7. We are then just going to multiply. So 3 times 8 is 24. 4 times 7 is 28. Is there a common factor for us to divide by? Well, in this case, 4 goes into both numbers. So 4 goes into 24 6 times, and it goes into 28 7 times. 2/5 divided by 3/7. Same again, let's copy the first fraction. 2/5. Let's change to a times, and we'll flip the second fraction. 2 times 7, well, that is 14. 5 times 3 is 15, and we have our final answer. And in our last question, 4/5 divided by 8/9, well, we'll copy the first fraction, we'll change to a times, and we'll flip to 9/8. And if we now do the multiplication, that is 4 times 9, 36. 5 times 8 is 40. What number goes into 36 and 40? Well, in this case, it's actually 4. And so that is 9/10. And we'll finish with the exam question. It came from the Edexcel paper in June 2017, and it was Foundation Paper 1. And in the first question, we've been asked to work out 5/8 times 3 quarters. So the first thing we need to think here, what is the method when we are multiplying fractions? Well, the method is simply to multiply. Multiply the top and multiply the bottom. 5 times 3 is 15. 8 times 4 is 32. We should be checking just to make sure if we can simplify or not. In this case, that is exactly the end product. 15 over 32 is the simplest form we can have. In part B, we're asked to work out 2/3 take away 1/4. And so again, in this case, we need to just be thinking, what is our method when we are subtracting? Well, when we subtract, we must have common denominators. And so the common denominator that we're going to need in this case, it had 3 and 4. So let's multiply those together. We'll have 12 as our denominator. How did I turn the first fraction into 12? Well, that was multiplied by 4. So 2 times 4 is 8. And how did I turn 1/4 into twelfths? Well, that was multiplied by 3. So 1 times 3 is 3. If I subtract now just the numerators, 8 take away 3 is 5. And so my answer is 5/12.